Did you know the sun's corona, its outermost layer, is paradoxically hotter than its surface? This is one of the most intriguing aspects of our sun, a cosmic conundrum that continues to baffle scientists. The corona, a halo of plasma, reaches temperatures millions of degrees hotter than the sun's surface. But why and how? This peculiar phenomenon is what we're going to explore today. So fasten your seatbelts and get ready for a cosmic journey. Join us as we unravel the top 10 mysteries of the sun's corona. Before we dive into the mysteries, it's crucial to understand the basics of the sun's corona. The sun, our very own celestial powerhouse, is composed of several layers. The core, the radiative zone, and the convective zone form the interior. The photosphere, chromosphere, and the corona make up the sun's atmosphere. The corona, the outermost layer of the sun's atmosphere, is a mesmerizing spectacle to behold during a total solar eclipse. It's a halo of plasma that extends millions of kilometers into space, far beyond the visible disk of the sun. It's also incredibly hot, reaching temperatures over 1,000,000 degrees Kelvin, which is paradoxically much hotter than the sun's surface. This plasma is threaded with magnetic fields which shape and guide it, creating beautiful, dynamic arches and loops. It's these magnetic fields that play a key role in the fascinating mysteries we're about to explore. Now that we have the basics down, let's dive into the first mystery. Mystery number 1. Why is the corona hotter than the sun's surface? This peculiar phenomenon has baffled scientists for decades. The sun's surface, also known as the photosphere, has a temperature of around 5,000 degrees Celsius. Yet, a short climb up into the sun's corona, and the temperature astonishingly soars to over 1,000,000 degrees Celsius. Several theories attempt to explain this intriguing mystery. One such theory is the wave theory, suggesting that waves carry energy from the sun's interior to its corona. These waves, upon reaching the corona, dissipate their energy, heating it up. Another theory proposes that small explosions, known as nanoflares, continuously occur in the sun's corona, releasing heat. These theories, while plausible, are not conclusive. There are still parts of this puzzle that elude our understanding. That's what makes this mystery so fascinating. While this theory holds water, there are still unanswered questions leading us to our next mystery. If you're finding these mysteries as fascinating as we do, hit the subscribe button, give us a like, and leave a comment below. Your engagement fuels our curiosity and helps us bring more intriguing content your way. Now, back to the mysteries. Mystery number 2. How does the corona influence solar wind? The solar wind, a stream of charged particles released from the upper atmosphere of the sun, is a crucial aspect of the sun's interaction with our solar system. Originating from the corona, these particles travel at incredible speeds, sometimes reaching up to 1,000,000 miles per hour. But here's the real conundrum. Why does it accelerate as it leaves the sun? You'd think the further away from the sun's gravitational pull, the slower these particles would move, right? Well, not exactly. The particles continue to speed up long after they've left the corona, a phenomenon that's left scientists scratching their heads for decades. And why does the solar wind matter? Well, it's responsible for the northern and southern lights and can also cause disturbances in Earth's magnetic field, affecting our technology. So, understanding the corona's influence on solar wind is not just a scientific curiosity, but a necessity. As we continue to ponder this mystery, let's move on to the next. As we move deeper into our exploration, the mysteries only get more intriguing. Let's delve into the third mystery. Why does the sun's corona create solar flares? These are sudden, intense flashes of radiation that can reach temperatures of several million degrees. The mechanism behind this dramatic event remains elusive to scientists who continue to investigate the complex magnetic fields within the corona. Some theories suggest that these fields can become twisted and snap, releasing a massive amount of energy in the process, but the exact process? Still a mystery. Shifting gears to our fourth mystery. How does the sun's corona affect radio communication here on Earth? It's a well-known fact that solar activities can cause disruptions in our radio signals. But the specifics of how the corona, this outermost layer of the sun's atmosphere, plays a role in this phenomenon is yet to be fully decoded. Theories propose that the charged particles in the corona could be interacting with the Earth's magnetic field, causing these disturbances. But again, this is a puzzle that scientists are still piecing together. Finally, we arrive at our fifth mystery. Why is the corona's structure so irregular? Unlike the smooth surface of the sun, the corona is a tumultuous landscape, teeming with loops, streams, and jets of hot plasma. Some scientists believe this irregular structure is due to the sun's magnetic field lines, which guide the movement of the plasma. However, the exact mechanism causing these irregularities remains unknown. It's fascinating, isn't it? The more we learn about the sun's corona, the more questions we have. It's like peeling back the layers of an onion, each layer revealing something new and unexpected. But that's the beauty of science. It's an ever-evolving field, constantly pushing the boundaries of our knowledge, forever pursuing the truth. As we dig deeper, the mysteries become more complex. Now we venture into the complex conundrums of the sun's corona. Mystery number 6 surrounds the formation of coronal loops. These are magnetic structures that arch from the sun's surface into the corona and back again. But here's the conundrum: why are they so uniform in shape and evenly distributed? Theories suggest that the loops are shaped by the sun's magnetic field, but the exact mechanism remains elusive. Our 7th mystery involves the sun's corona itself. It's 1,000,000 degrees hotter than the sun's surface. You heard that right, 1,000,000. This contradicts our natural understanding, where we expect the source of heat, the sun's surface, to be hotter than its outer layer, the corona. This puzzle, known as the coronal heating problem, has baffled scientists for decades. Various theories have been proposed, including the idea of nanoflares, small but numerous eruptions on the sun's surface, or the concept of magnetic reconnection, where the sun's magnetic field lines twist and snap, releasing heat. But a definitive answer still evades us. The 8th mystery is about the sun's magnetic field. It's known that the sun's magnetic field plays a critical role in shaping the corona. But how does it manage to exert such influence when it's supposed to get weaker the further it extends from the sun? Some scientists believe that the sun's rotation and convective motion under its surface generate a dynamo effect, amplifying the magnetic field. However, the details of this process are still under investigation. Each of these mysteries presents a unique challenge to our understanding of the sun's corona. They push the boundaries of our knowledge, driving scientists to devise new theories and conduct more detailed observations. As we move to the final mysteries, the questions become even more profound. Finally, we reach the most profound mysteries of the sun's corona. Mystery 9 concerns the intriguing nature of coronal loops. These are the bright, arching structures we see extending off the sun's surface during a solar flare. What makes them so mysterious? Well, it's their longevity. According to our understanding of plasma physics, these loops should dissipate quickly, yet they persist for much longer than expected. What's keeping them intact? Theories suggest magnetic fields might play a crucial role, but the final answer remains elusive. The 10th and final mystery is the sun's influence on Earth's climate. We know that solar flares and coronal mass ejections can cause geomagnetic storms affecting our planet's weather. But the exact extent and nature of this influence is still a puzzle. Scientists are hard at work using advanced models to understand this complex relationship better. And with that, we have explored the top 10 mysteries of the sun's corona. What a journey it has been, exploring the sun's enigmatic corona. We've delved into the mysteries of why the corona's temperature far exceeds that of the sun's surface, a conundrum that continues to baffle scientists. We've ventured into the realm of solar winds, investigating how the corona's influence propels these winds into space. Our quest also led us through a series of intriguing questions, such as the complex conundrums surrounding the sun's magnetic field and the role of plasma waves. And finally, we sought to unravel the profound mysteries of the sun's coronal mass ejections and the surprising discovery of nanoflares. The theories we explored, from wave heating to magnetic reconnection, offer tantalizing glimpses into the potential answers. Yet the sun's corona holds its secrets close, leaving us with more questions than answers. While we may not have all the answers, the exploration of these mysteries brings us one step closer to understanding our incredible sun.